Good morning all of you. Today's topic is torque measurement using by strain gauge. So now we define the strain gauge. A strain gauge is a device used to measure the strain on an object. In simple way, the strain gauge is a sensor whose resistance vary with applied force. It converts force, pressure, tension, weight into change in the electrical resistance which can be measured. Now we discuss about the strain gauge in following pattern. First introduction, second types of strain gauge, third strain gauge materials, and next selection of materials and advantage and disadvantage of strain gauge. Now strain measurements. When a metal conductor is stressed or compressed, its resistance changes an account of the fact that the length of diameter of conductor change, the value of resistivity of the conductor also change. When it is strained, its property is called piezo resistance. Therefore, the resistance strain gauge are also known as piezo resistive gauges. Now, so in again a strain gauge is a device which is used to measure the dimensional change on the surface of structural member under test. Strain gauge give indication of the strain only 1 points. Now we discuss about the types of strain gauge. So mainly 4 types of strain gauge are available. First, wire bonded strain gauge. Second, foil type strain gauge, semiconductor type strain gauge, and capacitive type strain gauge. We take first wire bonded strain gauge. These gauges are main two categories. First, bonded type and second, unbonded type category. In a bonded type, it is composed to fine wire wound and cemented on a resilient insulating support, usually a buffer unit. Next, unit may be mounted upon incorporated in mechanical elements whose deformation under stress are to be determined. Next point, while there are no limits to the basic value which may be selected for strain gauge resistance. Now these are the resistance wire strain gauge are available. Now foil strain gauge. In these gauge, the strain is sent with help of metal foil. Foil gauge have a much greater dissipation capacity as compared with the wire bonded gauge on a account of their greater surface or for the same volume due to the region they can employed for a high operating temperature range. In these gauge of the bonded better due to the large surface area of foil, the bonded foil gauge find the wider field of action. So the characteristics of foil types strain gauge are similar to those wire of bonded gauge, and their gauges factor are typically the same as that of wire bonded strain gauge. The resistance value of the foil gauge which are commercially available in 50 to 1000 ohms. Now these are the foil gauges in a very simple construction. Now semiconductor strain gauges. So we explain the semiconductor strain gauge in following points. First, semiconductor strain gauge depends for their action upon piezoresistive effect, that the change in value of resistance due to change in resistivity. Next, these gauges are used to their very high gauge factor and small envelope are required for semiconductor strain gauges. The semiconducting material such the silicon and germanium are used. A typical strain gauge consists of a strain sensitive crystal material and leads that are sandwiched in a protective matrix. The Production of these gauges employ of conventional semiconductor technology using and semiconducting filaments which have two thickness of 0.05 mm and bounded then on suitable insulating substance such the Teflon. Gold leads are generally applied for making the contacts. Now these are the semiconductor types strain gauges in simple construction and strain gauge materials. So these are the very important points for semiconductor type materials, strain gauge materials. So strain gauge sensing materials can be divided into two categories: metallic and semiconductor materials. The following five most popular metals are used in manufacturing of strain gauges. First, tungsten. It is an alloy of copper and nickel having a low controllable temperature coefficient. It finds application in static and dynamic measurements. Second, nichrome. It is the nickel chrome alloy that finds application in static and dynamic measurements. Next, dynelome. It is nickel chrome alloy find application in static and dynamic measurements. Next, stibulome. Dynoloy. It made up of nickel and iron which has a high gauge factor and exhibits high resistance to fatigue. Next, stibulome alloy. It is the modified nickel and chromium alloy, and platinum alloy. It is an alloy of platinum and tungsten. So these are the material which used for to make the strain gauges. Now, selection of material. Selection of material is important and based on the comparison of the following desirable characteristics. So the grid material should have all many of the following characteristics: high gauge factor, high resistivity, low temperature sensitivity, high electrical stability, high yield points, high endurance limit, good workability, good solubility of weldability, low hysteresis, and low thermal EMF when joined with other metals, good corrosion resistance. Now, some advantage and disadvantage of strain gauges. Advantage: these gauges have high gauge factor and excellent hysteresis characteristics. Disadvantage: linearity of these gauges is poor and manometer are used to up to 200 kN per meter square. Above this pressure, dead weight tester are used. Thank you.